So for people just coming in, we have some handouts in the front that you can take. I'll go through the syllabus for the first 10 minutes or so, and then I'll talk about the add-on policies, because I know that maybe more than half of you are not registered for the class yet. Okay, so you should have a syllabus, right? A one-page syllabus, and also the first set of slides for today's lecture and partly for tomorrow. Okay, so this is the only time that we will be printing out the slides for you, right? In the future, you will have to go to the website and download it yourself. All right, so in case you're in the wrong place, this is class EECS 202 on signals and systems, okay? So in this class, we will introduce the very basic mathematical tools to help us learn how to analyze, signals, both in continuous and discrete time. And this also involves understanding how to characterize these signals in different domains, in particular, the frequency domain, right? So we will introduce these basic mathematical tools to analyze continuous and discrete time signals, and also learn, how to, characterize it, how to characterize the behavior when the signal is passed through a linear time-invariant system, okay? So a linear time-invariant system is one of the most simplest type of system, right? It's both linear and time-invariant, okay? But understanding a system of this basic type is essential to understanding more complex systems. Okay, so these are the topics that we will cover throughout the semester. So starting today and tomorrow, we will, basically introduce some common signal types and how to characterize them. And then going on to chapter 2, we will introduce what we mean by a linear time-invariant system. And then we will focus the majority of the class on, introducing how to perform Fourier analysis on these signals, okay? So Fourier analysis basically, tells us that signals, like the majority of signals that we encounter, can be written as a linear combination of sinusoids of different frequencies, okay? So this is essentially, the most important thing that you will learn in this class, right? So most signals that we encounter can be written as linear combinations of sinusoids of different frequencies, okay? And we will show gradually, step by step, why this is the case, okay? So we will start out with periodic signals and show how to obtain Fourier series representation of these signals, okay? Basically, how to write periodic signals as linear combinations of these sinusoids, okay? Then we will extend to non-periodic signals, right? First in continuous time, and then in discrete time. After you understand that we can represent, a lot of these signals as a linear combination of sinusoids, right? We know that each sinusoid has a different frequency, okay? So then this, gives you an idea of, how to identify the different frequency components of a signal, okay? So each signal can be written as a linear combination of different frequency components, okay? So this is the takeaway message of this class, okay? So some people say that, if you just pick one thing to, distinguish an electrical engineer with some people in other fields, right? That one thing is that, electrical engineers understand the relationship between time and frequency, okay? And this is mostly taught, starting from this class, okay? So, right, with understanding of this, Fourier analysis, with understanding of the Fourier analysis, we then are able to characterize signals and systems in both time and frequency domain. Okay. Now, throughout this process, we're going to look at signals that are continuous and some signals that are discrete. Okay. Now, some signals are naturally continuous and other signals are naturally discrete. Okay. But sometimes in engineering, we would like to convert continuous time signals to discrete time signals. And this is because in modern technology, our circuits are more capable of efficiently processing digital signals, okay, discrete time signals, okay? And that is often done through sampling, right? So sampling is the process of, taking certain values from a continuous time signal to convert it from continuous time to discrete time. So sampling is the process of converting continuous time signals to discrete time signals, okay? And you will learn what is the relationship between the frequency domain characteristics of a sampled sequence and its original continuous time signal. Okay. So up to this point, we will be focusing on Fourier analysis. Okay. But one disadvantage or one downside of Fourier analysis is that it is only able to handle signals that are of finite energy. Okay? Now, in certain special cases, you may encounter signals that do not necessarily have finite energy. So in which case, you will need extended tools to help you analyze them. Okay? And these extensions are the so-called Laplace transform for the continuous case, right? And the Z transform for the discrete case. Okay? So you can think of these as extensions of the Fourier analysis to cases where signals are not necessarily finite energy. Okay? So this is basically what we will talk about throughout the semester. Okay? All right, so to take this class, you will definitely need calculus, okay? Because there's going to be a lot of integrals and derivatives, things like that. And it's also good to have some sense of linear algebra because we're looking at linear combinations of these frequency components, which you can think of as like basis elements if you've taken a course on linear algebra. Okay, so this is not a must, but it helps you understand some ideas, in more depth. So this is the textbook that we will be using. Okay. So almost everybody uses this textbook, right? This is the version I have now. So this is the new international version published by Pearson Education. But I think it's just a reprint of this old version, which was by Prentice-Hall. Okay? So this was actually my textbook when I was in undergrad. Okay? So you can sort of see that, this is a very popular book even after so many years. Okay? Right, so if you can, I would still recommend getting this one just in case that there are certain numberings of the problem sets that are different. Okay, so if you can, still get this one. Okay. But if you cannot, right, if you go to an old bookstore or something, I think this is also okay. The majority of the content is the same. But when you do homework problems, just try to double check if the problem numbers are the same. Okay? Okay, so this is actually the cover. I tore it apart into these different chapters. Okay. Okay, any questions up to this point? No? Okay. All right, so then there's the TA information. Sorry, I didn't introduce myself. My name is Peter Hong. This is my email. My office hour is Thursday morning, 10 to 12 o'clock. But if you want to come, it's always good to first send me an email so that I can make sure I am there when you come. Okay? And if you don't want to ask me directly, you can also contact the TA. Okay? 那个凯杰 the TA. 所以他是我们主要的 TA, but there will be other TAs helping out as well. Okay? So he has an office hour on Monday, 3:30 to 4:30, in our lab, which is in the ECS building. Where is that? I think it's the ECS building, 613. Okay? So these information you can find on the website in case you don't remember. Okay? And we will be using the E-class system. So try logging into that if you have not yet done so. Okay. So the grading policy is as follows. We will have 30% homework, 35% midterm, and 35% final exam. Okay. So I always have to emphasize this, right? So academic integrity is strictly enforced in this class. So no matter if it's a homework or an exam, never, never, never copy from somebody else. Okay, never copy from somebody else. Okay, and because this is more or less a math-oriented class, so if you do not do the practice yourself, right, it's very difficult to learn the material. Okay, so even if some homework set may be difficult, please try to do it yourself. Okay. So another thing that's very important is that, I understand that you have many different classes and you will have many homeworks coming along throughout the semester, okay? So sometimes you are not able to finish a homework, okay? But no matter how much you finish, right, let's say even 50%, 60%, 70%, please always try to turn in your homework, okay? No matter how much you have done, always turn in your homework, okay? Because if you do not turn in your homework, it's a definite 0 for that homework, okay? But if you do turn in your homework, you have, more or less, some score for that homework, right? And my experience is that, students that, fail the class are usually students that have not turned in their homework, okay? So people that regularly turn in their homework, usually do not have much problem passing the course, okay? So this is very important. Always turn in your homework, okay? So I have also pre-scheduled the midterm and the final exam. So please mark this on your calendar. So this will be Thursdays on week 8 and week 16, okay? Oh, so I should probably say first that this is that the university is, testing this 16-week semester policy, right? So we're one of the courses that are, testing out this thing. So our class will be 16 weeks. So our midterm will be on week 8 and week 16, okay? And you will also see that this is 1 hour beyond the regular scheduled time, okay? So just to give you more time to complete the exam, right? So please do mark this down on your calendar in case of any conflict in the future, okay? Okay, so like I mentioned, this is, 16 weeks, okay? And we have scheduled 2 hours on Wednesday and 2 hours on Thursday, okay? but the class is supposed to be 3 credits, right? So it's supposed to be 3 hours per week, but we scheduled 1 additional class for flexible use, okay? So I will usually use up maybe half of the 4th hour, but I'll try to not use up the entire 4th hour, okay? But that depends on how it goes throughout the semester. Okay? So this will be maybe 3+ hours per week. Okay. Okay. So, and one more thing that goes without saying is that, I really hope that you would ask questions. Okay, so please ask questions. So if you do not ask questions, it's very difficult for me to know like which part is more difficult for you and which part is easier and I'm going too slow. Okay, especially because we have people in different grades here, right? That have different background. Okay, so just let me know if you have any questions along the way. Okay. So that also brings us to the add-on policy. Okay, so from the system, I see that there are about 45 students successfully registered for the class. Okay, and there are maybe 70-something, 80 people that are wanting to add on, right? Maybe more that have not even registered for that. Okay, so the department is asking me to give priority to students in the ECS college, okay? So for those that have not successfully registered for the class, okay, and that your home department is not under ECS, okay, I will have to apologize to you. Maybe you will, find there's actually 2 more of these classes next semester, so I hope you will be able to take the class then. Okay. All right, so that will, give us maybe still 60-something people, okay, that are trying to add on that are under the ECS college. Okay. But I don't want the room to be too packed. So I'm planning to add on 55, okay? So maybe 10 or 20 of you will not be able to add this class. And I'll do that by asking the TA to take a draw this afternoon, okay? Right, so we have 45 successfully registered, 55 that we will draw this afternoon. That will add up to 100, okay? But I think somewhere around 90 to 95 is better, right? So after adding on the 55 to get up to 100, I will ask the department to set the quota to set the capacity to 95. And then, because many students will drop the class, right? So if it drops below 95, then just try to add it on, by random selection on the system. Okay? It's a little bit complicated, but the main thing is that we just wanted to give higher priority to students in ECS. I think that's the main reason for this. Okay, so a lot of people are discussing, so there must be some questions. Okay, I know that this is a very basic and important class, so many of you would like to take it sometime, right? But each class has a limited capacity, so I really apologize for that. Okay, but as I mentioned, next semester is the main semester for this class. Okay, so there will be 2 classes on this next semester. If there are no questions, I'm going to continue with the class. If you would like to leave, it's okay. It's okay with me. Okay. So how about we take a 5-minute break, so that, people would not be embarrassed of leaving. So let's come back at 150, okay? 150, and then we'll go on without break till the end.